So as a mechatronics engineer, I don't believe in playing a fair fight, so I don't believe in just doing software versus software. Adding the switch to this was a very simple and obvious way in which I could make it impervious to all remote exploits by plugging it out automatically so the user doesn't have to. You can consider the fact that unlike Yubikey, I actually keep this as just a hardware-based device that interacts with the computer. This Yubikey is designed that it requires an authenticator app to be registered, meaning that the software is the weak point. Aside from that, it was also designed to be exploitable through brute force. They intentionally created just enough characters knowing that it wouldn't be something that I could brute force here on my computer, but if someone has enough incentive, then they can afford the capital in order to create the brute force to get in the device. Now, why would they do this? Well, because as they move people from one group, right, from their series 4 and 3 and lower to their next group, eventually all the people in this group become a larger target, more incentive to go and breach that device. So on this page, I just wanted you to see how strongly they use semantics, that they have to define them in order to make sure that they're legally in the right. And as you look at this HOTP and TOTP options over on the right, I just wanted to show you that this protocol is linked to the YubiKey Series 5. For all practical purposes, leaves out what would be considered impractical purposes, and that seems important to me, seeing as how they defined a list of semantics earlier. On distinct counter inputs assumes that no one would ever manipulate the inputs and create an indistinct input. We'll get to that later. Here they say negligible bias without any sort of error bar rating, which means it's completely arbitrary. What you consider negligible and I consider negligible are two different things. So at the bottom left here, we're looking at what they assume to be a reasonable breaching situation, without taking into consideration the fact that whoever's observing this protocol changes and collecting the sequences would be more likely to just interact with it directly, manipulating the system, so that way they don't have to observe them. They can just create them. Even just making your own website and just having it basically be compliant and send these fake signals back and forth, you don't have to just observe. And then the fact that they said will not have a significant advantage makes me concerned as to what would be considered a moderate advantage and if that is included in this definition or not. Looking at the fact that they have the TOTP algorithm, it's basically just a time-based algorithm. It just counts the seconds since some previous point in the past. I believe it was in the 70s. That is a problem because you can just update the timer on your computer at any point in time. All right, the HTOP is just basically the hardware counter that takes into consideration not just the time, but also different things like how many times the button has been used and how many times the device has been powered on, since it's never going to be used less or powered on less amount of time. All right, to create one-time passcodes, they have these functions that basically have to have an input that changes, right? Because for any one input, you're only going to get one output. And so for their random function, what they use is a computer time from like a point in the 70s up until now in seconds, the amount of time that the USB has been powered on and off, because that's going to always go up sequentially, and also a touch counter. Now, when your variables are no longer large enough to store the values, it's going to overflow. So like, let's say it overflowed at 7 billion. At 7 billion and 1, it's going to actually be at 0 and start over, meaning that any way in which you go about manipulating these, you can end up using that whole understanding to basically create your own function and then therefore your own key, if not provided one. You can also just create a website that interacts with it as if it was authenticating your entry, and then it'll provide you with a key, and then basically you can use interactions back and forth between that to create your function, which will be universally useful. Or you can simply use brute force because they left that as an option. The reason why YubiKey leaves the option to brute force it is because they understand that as they move their clients from the older versions to the newer versions, there's going to become a point in time when there's enough people here that it becomes attractive enough to actually create your own exploit or to actually fund a brute force to make your way in. Now, the reason why they want people to break into the Series 5 is because they need to have a reason to have the Series 6. And so when the Series 6 comes out, the Series 6 is going to have 0 exploits. It's going to have 0 breaches. It's going to look very, very attractive to everyone that was on the 4 or the 5. And so then they're going to be incentivized to move over. Mine, just random analog noise. You ever touched an analog cable and you've heard the static? The wires around your house, even the device itself, just constantly making all these random noises, and it's always picking that up in an effort to use that as my seed, along with a random millisecond counting function. So if you plug it in the device, it's going to start counting in milliseconds, and between that point in time and when you press the recycle button or the update button is when it's actually going to pull that time to use in the random function. So if you plugged it in and you tried to do it the same time every time, it would be nearly impossible because there's 1,000 individual points between each second, making it very quick. There's also other options that I have available to increase the randomness even further. I also want to demonstrate something here, just showing you guys the basics of this. Right now, what you were looking at was just the controller with some resistors. The reason why I kept this as simple as I did was simply because I wanted it to last as long as possible. I see no reason why this wouldn't go well past 10 years and way further than that. So the only reason why I wouldn't give you any quote past 10 years is just because I haven't seen too much information past 10 years. But at this right here, it's so simple. There's just not very many things that can go wrong with it. So feel free to add customizations. Just understand that as you add things to it, it's not just going to increase like the relative cost of the the total components of manufacturing, but as you add more complex things to it, it's going to be more likely to fail under certain situations, which I can plan and prepare for. And I'll also warn you, there's never going to be a situation where you're going to be at risk the way you are at Yubikey, because I am not designing this with the intention of taking your security away from you after a certain amount of time.